Good morning, class. We will quickly go through the chapter. Children, today I will not be sharing the screen because of certain network issues. But open all of you the chapter major domains of the earth. And last time we did till the major domains of the earth, where we have to now begin with lithosphere, that is domain of land. Okay. The solid outer layer of the earth is called the lithosphere. Just a second. I will just see if we can do anything. I think I can share. Okay, is the screen sharing, children? Just let me know.
Yes,
Yes,
mom.
ma'am.
Yes, ma'am, the screen is
Okay,
sharing.
okay. Then it's okay. Switch off your mics so that the network is not disturbed. Okay, the solid outer layer of the earth is called the lithosphere. That means the outer layer of the earth is called lithosphere. It comprises rocks and minerals of the crust and the thin layers of soil over it. So now this outer layer is basically made up of the rocks and minerals. And then thin layers of soil, that is mud and all, over it. Okay. About 29% of the Earth's surface is covered with large land masses termed as continents. The rest, 71%, is covered with water. The huge water bodies surrounding the land masses are termed as ocean basins. Now, when we look at the Earth from a satellite, we know that the earth is made up of two components, basically the landed area, that is lithosphere, and the huge land masses, as we all know, are called continents. Clear? Just as the other part of the earth is made up of water. 71% of earth is made up of water. That is why it is a blue planet. So those water bodies, the huge water masses that surround the earth, the land masses, they are called the oceans. So the biggest water body is ocean, and the biggest land mass is called continent. So we know that the earth, if we see through a satellite, it forms two major distinctions, the land mass area and the water bodies. So 29% of these land masses are the huge continents, and the remaining 71 are the oceans. Now, the Earth's outer shell, the crust, is thickest under the continents. Now, wherever we talk of the continents, those are the big land masses where the Earth's crust is thickest. Near to the shore, it is not that thick, but right in the center of the continent, it is the thickest. Now, the thickness averages 30 to 40 kilometers but extends as far as 70 kilometers beneath the highest mountain ranges. Under the oceans, the crust is thinnest, that is averaging from 6 to 11 kilometers. So now they are telling you that just beneath the continent, if we see the continent, the Earth's crust is as thick as about 70 kilometers, from 30 to 40, and the maximum is 70 kilometers thick soil you will find beneath the continents. But in the water bodies, if you go to the depth of the ocean, there the earth crust is thinnest. It is just 6 to 11 kilometers. Okay. This first diagram, as I told you, we want this to be done. You remember? I want this diagram as well as this diagram. Okay. Now, coming on to this, the lithosphere is not uniform in shape. It may range from high mountains to deep ocean trenches. Now, we all know that lithosphere, that is the soil area, is not evenly given. It's not that the shape is uniform. At certain places where the high mountains are, the soil has even extended itself and is high. whereas in trenches it is deep also. Yeah. So figure 5.2 shows you that the highest point on the Earth's surface is Mount Everest. Now, can you see this picture here? Mount.
Yes, ma'am.
This picture tells you very clearly. See the highest mountain, the highest landmass. This whole thing is a landmass. This is the length of the landmass. So here it is the highest point of the earth is Mount Everest. Whereas the deepest trench, can you see this area? The deepest trench of the earth is the Mariana Trench. Please underline Mariana Trench. Okay. It is 11,033 meters below the sea level in the Pacific Ocean sea floor. So in the Pacific Ocean, it is the deepest point, the trench, and the Mount Everest is the highest above the ground as a landmass. Clear? So these two things you have to remember, and please make sure that you do the third diagram now, and that is this one. Okay. So for today, when you go, you will do this, the glossary plus these three diagrams. Okay. Now coming on to did you know? A narrow strip of land connecting two land masses is called an isthmus. Underline isthmus. That means that that particular land strip which is connecting two land masses from each other is called isthmus. A narrow channel of water connecting two oceans or seas is called a strait. Underline strait. Now, whereas two water bodies or two oceans are getting connected by a small little narrow stream, that is called a strait. But when two land masses are connected with each other through a small little strip, that is called a isthmus. Okay. Now I'll show you one example. Wait a second. I'll show you. Can you all see this area? One landmass getting connected with the other. This is a small strip of area. This is called an isthmus. Okay, this area. Clear? Now, can you see at the same time this area where this water body is getting connected with this water body? Or can you see this area? This huge water body connecting with this water body in this narrow space here. This is called a strait. Okay. Or you can you see India? Now, if you see India here, uh, Sri Lanka, and just above there's a small little land area plus water area. Both are here. Okay. So when a land is connected with another land, it is isthmus. When water, that is specifically ocean, connected with another ocean with a stream of water, it is called a strait. Is this much clear to each one?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes,
Okay.
ma'am.
Look at the map of
Yes,
the
ma'am.
world. Look at the map of the world. You will see that there are seven major continents and four major oceans. Underline seven major continents. Underline four major oceans. Now observe carefully. You will see that all the oceans are interconnected. The level of water thus remains same everywhere. This is termed as sea level and is taken as zero. Elevation on land and depth of water bodies are measured from this level. Now again, they have told you that in a water body, in a water body, the level of water remains constant. If you place water in a glass, you will see that it is always straight. Can you see this line above where the ship is sailing, it is basically one straight line for water. Clear? So that line is called the sea level. Now this is taken as 0 degrees. The sea level is taken as 0 degrees. Can you see sea level written here? It is taken as 0 degrees. And see, it is the degree is also written here. Can you see 0 degrees here? Can you see the 0 degree written here? So everything above the sea is we say it is above the sea level. Anything below the sea, the trench is below the sea level. Okay. So we take this into account through the level of the sea. Okay. Now observe the map once again. Are the land masses interconnected? If you bring them closer to each other, you can fit them like a jigsaw puzzle. So most of the land masses once upon a time were interconnected, but water bodies are still interconnected, and throughout the world, in the whole earth, on the whole earth, the water level is nearly leveled because the water is connected through these land masses. They cross over and surround it, and they are well connected with each other. Clear? Interesting facts. Geologists think that originally all the continents were clustered together as a single continent. According to the theory of tectonics, the Earth's crust is made up of large blocks or pieces called plates. These plates float over molten magma and over and move relative to each other. When they diverge, ocean basins may be formed. When they diverge, oceans may be formed. When they converge, mountains may be formed. When they may also slide against each other. The present position of continents and oceans are due to tectonics. Even now, these continents and oceanic plates are moving in relation to each other. Now, basically, you just need to know what are tectonic plates. So these are the different layers of the earth, and they are constantly clashing with each other. So once they come in close contact, these plates, then because of collision, they form mountains. But supposing with the movement, if they are moving away from each other, these tectonic plates, that means the soil plates or the different layers, then when they're diverging away, then they form the oceans. Clear? So once upon a time, these continents were one huge bulk of mass, but with tectonic movements underneath the earth, the magma had made a movement on the earth's surface, and then it resulted into breaking down of continents. And today, present day, we have nearly 7 land masses or the continents into which the landmass has broken up. Clear? We stop till here. Tomorrow, next time, we'll take the continents. Okay? We stop here now.
Okay, ma'am.
Okay, ma'am.